This is an overview of arithmetic. Arithmetic is what we learn as math in elementary school and before we learn algebra. I tried to make an extensive list of many different topics, as many as I can think of. And I do not go into detail about the actual computational practice that's required to master any of these specific skills, but nonetheless I want to compile a bit of an overview to try and summarize all that there is. So arithmetic is a foundational branch of mathematics that deals with numbers, their properties, and the basic operations performed on them. Now these are some topics, concepts, and skills of arithmetic. And the order of this, I'll try to build on itself. So what we learn in the beginning will build on what we learn later on. So there are whole numbers, which are also known as natural numbers. These are the natural numbers. We can use these natural numbers to count individual objects, such as here. There's 7 stars. These numbers can be even or odd. Here are the even numbers, here are the odd numbers. Every digit that makes up a number corresponds to a specific place value. Now this is a very large number. The place values go ones, tens, hundreds, thousands, millions, billions, etc. We have names for many of the large place values. Numbers can be approximated by rounding up or down, such as this number can be approximated by this number. The symbol translates to the saying is approximately equal to. A rounded number has a certain number of significant figures, which is the numbers that are not 0, or the numbers before the string of zeros, such as 1 sig fig here, 2 here, 3 here. Different numbers can be compared by indicating which of the numbers are larger and which is smaller, and we can do this by using inequality signs. In this case, here, and also here. This would be the less than sign, this would be the greater than sign. There are operations that can combine numbers together. There are 4 elementary operations. There's addition, subtraction, multiplication, and division. There are also equal signs, which is a symbol that we use to indicate if 2 numerical values are the same. It looks like this. Addition combines the numbers' values together. So 3 plus 4 equals 7. 3 and 4 are called add-ins, and the result is called the sum. And a skill at this point that we usually learn is adding large numbers in this fashion. Addition by 0 does not change the value of the non-zero addend. There's also subtraction, which takes away the value of the second number from the value of the first number. The result is what remains. So in this equation, 9 minus 3, 9 is called the minuend, and the 3 is called the subtrahend, and the 6th, the result, is called the difference. And in this case, subtraction, it matters the order of these two numbers. And a skill at this point is subtracting larger numbers, such as like this, in this fashion. Subtraction by 0 does not change the non-zero minuend in this case. Multiplication is essentially repeated addition. So in this case, 6 times 5 is the same as 5 added 6 times, or 6 added 5 times. These two numbers that are being multiplied are called factors. The result is called product. A skill at this point in terms of multiplication is memorizing times tables. Another skill in terms of multiplication at this point is multiplying larger numbers in this fashion. Multiplication by 1, such as 13 times 1, does not change the value of the non-1 factor. Multiplication by 0, no matter what the other factor is, it will always equal 0. This is called the zero product property. Division is essentially counting how many times subtraction can be repeated until we get to 0. Now in this case, we can have 24 divided by 8 equals 3. 24 would be the dividend, 8 would be the divisor, and the result, 3, would be called the quotient. And it can be visualized by this repeated subtraction. A skill at this point is long division, and in which we can have a remainder, such as like this. Division by 1 does not change the value of the number. Division by 0 is always undefined, unless it's 0 divided by 0, in which case it's indeterminate. Inverse operations undo each other, essentially. Every operation has an inverse operation pair. Addition and subtraction are inverse operations, and multiplication and division are inverse operations. And you can see here, performing them both with the same number undoes the change for both addition and subtraction and multiplication and division. Now, an expression is a collection of numbers that are held together by operations, such as this. An equation consists of expressions that are declared equal by an equal sign, such as like this. An equation can be true, such as this one, or it can be false, such as this one, in which case we use a unequal sign. Now there's also expanded notation, in which we can represent a number as a sum of its constituent place values. In this case, this number can be represented as 7 times the 10,000s, this times the thousands, this times the hundreds, times this times the 10, times the 1, plus the ones. We can estimate operations. Estimation is a process of rounding and then performing a comparably easier calculation. So for example, this number plus this number is approximately equal to this number plus this number, which is this number. So we can estimate there. There are also negative numbers, such as this one and this one and this one. The collection of negative numbers, whole numbers, or the collection of negative whole numbers, positive whole numbers, and 0 is called the integers, denoted by a fancy z. This would be the set of all integers. A number line can be visualized. It is a visual display of numbers, commonly integers, like this. To the left, as we go left, the value decreases. As we go to the right, the value increases. You can compare integers using inequality signs, such as here. The absolute value of an integer is its distance from 0 on the number line. So the absolute value of a negative number is positive. The absolute value of a positive number is also positive. Adding a negative is the same as subtracting the positive. So in this case, this is equal to this, which is equal to this. Subtracting a negative is the same as adding the positive. So if we have this subtracting a negative, we can change the both signs to addition, and it's equal to this. Multiplying negatives, we have to follow some rules. We can treat it as the same thing as multiplying the positives, but you have to follow the sign changes. So these are the sign changes. Positive times a positive will be positive, negative times a negative is positive, and this will give you a negative. Dividing negatives, we perform the division as per usual, and we follow the same sign changes as multiplication, same sign changes. Multiples of a number are the possible products of that number. So for example, these are the multiples of 7. The least common multiple between two numbers is, in fact, the common multiple is the smallest common multiple. In this case, for 4 and 6 is 12. Factors of a number are all the numbers that can divide that number with no remainder. So for 24, these are all the factors. Each of these numbers can divide 24 with no remainder. The greatest common factor between two numbers is the common factor between both of these two numbers that is the largest. So in this case, 2 and 4 are common factors, but 8 would be the greatest common factor. Here are some divisibility tricks for 2, 3, 4, 5, 6, 7, 8. Or not 7, 8, 9, and 10. Prime numbers are numbers that only have two factors, 1 and itself. These are some primes. Composite numbers are numbers that are not prime. A prime factorization is the set of all prime factors of a number. So 36 would have this prime factorization. And there is the fundamental theorem of arithmetic that says every number greater than 1 has a unique prime factorization. Now, there are fractions, ratios, or rational numbers. These are all the same thing. Each consists of a numerator divided by a denominator. These are all examples of fractions. The set of rational numbers is denoted by a fancy Q. You can add fractions, which requires a common denominator, like so. And you can subtract fractions, which also requires a common denominator, like so. And you can multiply fractions, which can be done by simply putting the product of the numerators over the product of the denominators, like so. The reciprocal of a fraction can be obtained by simply flipping it. Dividing fractions is the same as multiplying by the reciprocal of the divisor fraction. So this division is the same as this multiplication, which is this. We can reduce fractions, which is done by dividing out common factors between the numerator and the denominator, like so, for example. Mixed numbers consist of a whole number and a fraction, like this. Improper fractions are fractions where the numerators are larger than the denominator, like this. You can convert between mixed numbers and improper fractions, like so. You can add, subtract, multiply, and divide improper fractions the same as any other fraction. Now there are decimals. Decimals have digits in the place values that are smaller than the ones. There is a decimal to the right of the ones digit. This is an example of a decimal number. These would be the place values of each of some of the decimal place values. When adding or subtracting decimals, line up the decimals here, line up the decimals here, and then perform the operation like so. When multiplying decimals, you do not have to line up the decimals. You can proceed normally, but for the product, we shift the decimal by counting how many total decimal movements are in each of the factors. For dividing decimals, the easiest way is to, if we have a decimal in the divisor, we can shift it to the right and also shift the dividends decimal the same number of times to the right, and proceed as if we're dividing by a whole number. Decimals can terminate, in which case they are rational, like this one. Decimals can also repeat, also in which case they are also rational, such as this one, that's rational. But decimals that don't terminate nor repeat are considered irrational, such as pi. Rational numbers can be expressed as a ratio of two integers. Irrational numbers cannot. For converting fractions into decimals, we can take the fraction and we can simply perform the division, and then we get the quotient as the decimal. Converting decimals to fractions, for those that terminate, can simply be put over a power of 10, such as this terminates, this can be put over this power of 10. Those that repeat can be put over some 9s, such as here, 6 over 9, or this one, 23 over 99. Now, there are percentages, which range from 0% to 100%. To convert a decimal to a percentage, move the decimal point 2 places to the right. So this would be equal to this as a percentage. To convert a percentage to a decimal, you simply move the decimal 2 places to the left. So this would be equal to this as a decimal. You can round decimals to a certain number of sig figs, the same way you can round other numbers. For example, this number is approximately equal to this number, which would have 4 sig figs. We can also compare decimals like any other number with using inequality signs. We can also compare fractions, and in doing so, a common denominator is helpful. Let's say we're comparing this fraction and this fraction. We can get a common denominator and then compare the numerators. The additive inverse of a number has the same absolute value, but the opposite sign. So these are additive inverses, these are additive inverses. The multiplicative inverse of a number is simply the reciprocal of that number. So these are multiplicative inverses, and these are multiplicative inverses. They have the same sign, keep that in mind. Subtraction can be generalized or simplified as the addition of the subtrahend's additive inverse. So if we have this subtraction expression, we can simplify this to the addition of this number's additive inverse. Similarly, division can be simplified as the multiplication of the divisor's multiplicative inverse. So for example, this expression, this division expression, can be simplified to this multiplication expression, where this and this are multiplicative inverses. Addition is commutative, which means this is true. It doesn't matter the order of the addends. Multiplication is also commutative, which means the order of the factors do not matter. Addition is associative, in which case we can add partial sums, whichever partial sum we want. Similarly, multiplication is also associative, so we can group these together differently and the results are still the same. And multiplication is distributive over addition, which means that an expression like this is equal to this. We can distribute. The additive identity is 0. The sum of any number and its additive inverse is equal to 0. The multiplicative identity is 1, and the product of any number, and its multiplicative inverse is 1, such as here. Exponentiation is repeated multiplication, like so. If the base is negative, given an exponential expression, if the base is negative and it has an even exponent, the result will be positive. However, if the base is negative and the exponent is odd, the product will be negative, such as here. A negative exponent indicates the reciprocal, so this would be equal to this. And there are some exponent rules regarding the same base. When multiplying, we can add the exponents, like so. When dividing, we subtract the exponents, like so. Anything to the 0 power is equal to 1, like so and like so. A fractional exponent indicates a root, like square root or cube root, and so on, such as this will be equal to the square root of 4, which is 2. This would be equal to the fourth root of this. We can keep the numerator of the exponent and treat it normally. There are logarithms, which is the inverse of exponentiation. This is an example of a logarithm. This number is called the base, this number is called the argument. And this equation is equivalent to this equation. We can translate it to an exponential equation. Now there are log rules, such as the sum and product rule, difference and quotient rule, and exponent rule for the log. The log of 1 is always 0. The log where the base and argument are the same number is always equal to 1. And 2 raised to some log with the same base as the base is equal to the argument. And there is no such thing as a log with a negative argument. This will always be undefined. We can simplify / evaluate expressions by performing the operations according to the order of operations known as the famous acronym PEMDAS. So like so, we can do this. In PEMDAS, P stands for parentheses, E is exponents, MD is multiplication, division, A and S is addition, subtraction. So we can simplify expressions like so. We can also express numbers in scientific notation, such as large numbers like this. We can move the decimal over and simply represent it as the multiple of 10 with some exponent. We can identify patterns in sequences of numbers. There are arithmetic sequences, such as this one, where there's a common difference between each consecutive number. There are also geometric sequences in which there's a common factor between each of the numbers, and we can guess the next number in both cases if we know the pattern. We can also consider modular arithmetic, such as this would be a congruency statement using modular arithmetic, which basically says 28 is congruent to 43 mod 5. This is true because 28 divided by 5 has a remainder of 3, okay? Also, 43 divided by 5 also has a remainder of 3. Therefore, these two numbers are congruent mod 5. And that's it. That is as much arithmetic as I could think of over the past couple days. So what is next? Algebra is next, and the uses of symbols as variables to represent changing quantities. This idea of variables turns out to be very powerful. I'll see you in the next one. Thank you very much.